Okay, so we're going to pick up where we were yesterday. We're going to do some logarithmic review, and then we're going to get into our new notes. And so we want to be able to graph these exponential functions and describe their transformation. So we'll just look at a couple of these together, and then we'll move on. But y equals 4 to the x, that just looks like the parent function of an exponential function. Do you remember from yesterday, what coordinate do all exponential functions go through? For a parent function, 0, 1. Yep. So because anything to 0 power is 1. So, you know, whether it's 4 to the x or 5 to the x or 10 to the x, without other transformations, it passes through 0, 1. And has a horizontal asymptote of y is equal to 0. If you have y equals 1 over 4 to the x, that's the same as 4 to the negative x. Do you agree that those expressions are the same? So what kind of transformation would 4 to the negative x be? It would be flipped vertically or horizontally. It's a horizontal flip. If the negative is on the outside, such as letter D, then it would be a vertical flip. If the negative is on the inside, then it is a horizontal flip. So as you can see, it starts up here and goes like that. So if you have a number that's less than 1, then that's going to be the graph. Again, it goes through 0, 1, and it has a y equals 0 asymptote. So let's look at one that you maybe don't know how to do as readily or as easily. Let's look at F. First of all, what does 2/3 look like? Is it going to look like the first one or second one? Second one. So I'll just draw the parent function. This isn't the actual graph. Now, there's two transformations happening. What are the transformations that are happening? Right 2 and up 1. So if I take this point, which is at 0, 1, and I move it to the right 2 and up 1, what's its new location? 2, 2. Right? Now, because I take this point, 0, 1, I move it to the right 2, which is 2, 1, and then I move it up 1, so 2, 2. Now, the horizontal asymptote was y equals 0. Does a horizontal shift affect the horizontal asymptote? Does a vertical shift affect the horizontal asymptote? Yes, so it's going to move the horizontal asymptote of y equals 0 up to y equals 1. So I have a horizontal asymptote of y equals 1. You can see that it then does this type of thing. So you should be able to take these and change them based on their transformations. The 2/3, if the number is less than 1, it means it's going to do that. If it's greater than 1, it's going to do that. But whether we graph, the graph of y equals 4 to the x and 5 to the x are essentially going to look the same. It just might be stretched a little bit more than the other. Okay. So it would be like if I asked you to graph y equals 2x squared and y equals 3x squared, it'd be like, well, they're not that much different, are they? So, okay, let's look at the logarithmic graphs. The parent function for a logarithmic graph is going to be the inverse of the exponential graph. So if I took this graph, this was the aha moment yesterday, and I flipped this over the line y equals x, okay, what would this point become? 1, 0. So this goes through 1, 0. And instead of having a horizontal asymptote, it will have a vertical asymptote. So the graph of log base 3 of x looks like that. It is the inverse of the exponential function. Do a couple more together. What if you do log base 2 of x minus 2, parentheses around the x minus 2? I think, no, that's not what I wanted. I want to do the x minus 2. What is the transformation that's happening here? Down 2. So the coordinate 1, 0 will move to, yeah, so 1, negative 2. And does that affect the horizontal or the vertical asymptote? Does not affect the vertical asymptote. And let's look at L. How is L different? 3 transformations and natural log. Natural log is the same as log base e. So the parent function for natural log is the same as this one right here. Okay? So I'll draw the parent function. Goes through 1, 0, and just like that. Okay? So what is our transformation? And by the way, we perform the transformation in the order of operations in which they occur. So what is the first transformation? Left 1. So does that affect the point? Yes. Does that affect the vertical asymptote? Yeah. What happens next? Yeah, so the 2 would be a stretch and the negative would be a vertical reflection, correct? Does that change this location of, if I vertically reflect this, does that change the location of this point? Does it change the location of this vertical asymptote? If I reflect it vertically? No. How about adding 2? Does that change the location of this point? Yes, it will go up 2. So I'll have a coordinate of 0, 2. And then instead of the graph starting down and finishing up, it will start up and finish down. Oh, kind of missed that there. No, no, we won't show the stretch. We would have to plot more points to show that, and we're just not interested in that. So that finishes up what we did yesterday, and that's what you want to be able to work through, um, the rest of that. So that's the first part of your assignment. We will have a final exam this class next week, Wednesday. It will be just a one-period exam. It will be on really the content that we are covering right now. Do you know how to use the product rule, quotient rule, chain rule? Do you know the derivative sign? What is it? Cosine. Do you know the derivative of natural log of x? Nope, it's 1 over x. And so those are the pieces that you're going to learn these next few days. They're not that difficult, but you will learn them. So let's go to this piece right here. As the calculus of logarithmic functions. I'm sorry, of exponential functions. I moved ahead. Yes, I want you to finish everything in that review packet. That'll be part of your assignment. I did not make up the answer key. I will put that on my to-do list. And I didn't get your grades updated here. I did grade the trig test and the homework, but and then now I have the college algebra test to grade tonight. So I'm going to do my darndest during college algebra to kind of update things and get stuff ready to go. So as they're taking tests today, I'm going to try to get other stuff done. So the calculus of the exponential function, and the calculus means the derivative. If you want to see this proof, you can check in your book or see me after school. But the derivative of e to the x is the most wonderful derivative in the world. The derivative of e to the x is e to the x. And so for all that time you spent, in college algebra asking yourself, what's the point of e and why do we do natural log? It's such a nice function because the derivative is itself. Is that nice? So I told you. All right. Here we have another one. What if the base is different? Suppose the base is 2 or something like that. You have a base of b. The derivative of b to the x would be the natural log of b times e to the x. Oh, no, times b to the x. What am I doing? This makes sense over here as well. What is the natural log of e? That means e to what power is e? So the natural log of e is 1. So if you apply the same formula over here, natural log of e is 1 times e to the x. So it works out. So anyway, let's try some examples so you can see exactly what we're doing. Find the derivative of the following. What rule do you think we use to find that derivative? Product rule. And so the derivative of the first part is 3x squared times e to the x plus x to the third times, what is the derivative of e to the x? E to the x. You can leave it like that, you're done. If you'd like to, you can factor out the e to the x and raise x to the third plus 3x squared. One is not more simplified than the other. If you're able to combine like terms by factoring, then one would be more simplified. The fact of the matter is these are the same.
and I'll accept either on the test. Yep, if you wanted to factor out x squared e to the x, and that'll be an x plus 3, that'll be acceptable as well. Doesn't matter. Thank you, Kyle. All right, go get some brain food, come back more intelligent, we'll get going. All right, here we are. So we did A, now we move to B. We need the derivative of e to the 4x squared. Anybody tell which rule we use to find this derivative? I use a chain. Now you might be wondering, why do I use a chain? Well, think about it. If you were to plug in a number, you would square it, then you multiply it by 4, and finally you take e to that power, right? So I can write this as a composition function, e to that power. So the inside function is 4x squared. What's the derivative of 4x squared? Derivative e to the u, e to the u. Multiply the two together, 8x e to the 4x squared. That's my answer for box room. How's that? You like that, huh? Yeah. All right. C, what rule? Quotient rule. Derivative of e to the x. E to the x times 2 minus x minus e to the x times derivative bottom, -1 over 2 minus x, that quantity, squared. The f prime of x is equal to, so I can have 2 e to the x minus x e to the x plus e to the x over 2 minus x quantity squared. Can I combine any like terms? That 2 e to the x and e to the x make 3 e to the x minus x e to the x all over 2 minus x, that quantity squared. In your answer, you must make sure that you can combine you combine like terms if you can. Okay? That's it. That's your answer. It doesn't matter. Yep. Okay, flip it over. E to the 3 sine cubed of the square root of x. Best problem of the day. What rule? Okay. So I have e to the u, and then it's not the cube root of the square root of x, it's 3 sine cubed of the root of x. Root e to the u, root of 3 sine cubed of the root of x. There we go again. I ain't seen nothing yet. I hear you, man. All right. All right, so 3 sine cubed of the square root of x. See if you can identify what the outside is. Very good. Close. What is it that you are cubing? You're cubing the sine of the root of x. So we go back to order of operations. The 3 is just a constant. It has no bearing on whether we set the product or the portion or anything, right? So as I look at the sine cubed of the root of x, I look to my order of operations. Square root then sine, then cube. So that's why the cube is the outermost, and the 3 just comes along. Let's see that. Okay, so now I've got this. Derivative 3 to the third. 9u squared, derivative sine of square root of x. Okay, all right, we're gonna like it. It's on the final. So we have sine of u, and yep, you do something else, but you get it wrong. Um, Cosine of u and the derivative of the root of x. So now I can use that to write my derivative in this box and multiply the two together. I get the cosine of the root of x over 2 roots of x. Now I will multiply these together to get something in this box. So I have 9 times sine squared of the root of x times the cosine of the root of x all over 2 roots of x. And now I will multiply this by this, right? So we have e to the 3 sine cubed of the root of x times that 9 sine squared root of x cosine of the root of x over 2 roots of x. I think I actually wrote it during first hour, the second hour. I think I wrote it like this instead. 9 sine squared root of x cosine root of x e to the 3 sine cubed root of x all over 2 roots of x, and I would accept either or. Really that big of a deal, I'll just simply here. So, oftentimes with exponential or logarithmic functions, we end up doing this for sort of the chain rule, for sure more than once. Was second equation. also gave you a various calculus sheet, and on there are all the derivatives that you ever want. You do need to know those, so I'm not going to go into secret thing. Right. Derivative of e to the a